Hey everyone, I hope you guys are doing great. This is the first video of the series, and today we'll be looking into some very interesting SQL and PySpark interview questions asked in companies like Microsoft, Google, Amazon, GPMC, Hotstar, and many more. As these questions are directly taken from my interview rounds, so the questions are basically pasted into my notepad, and we'll look into them from scratch how we can build an intuition and how we can solve the same question in both SQL and PySpark. Knowing how to solve in PySpark becomes very important for data engineers because if you don't have an hands-on experience in your current job where you solve PySpark questions or where you are writing ETL logic in PySpark, then you might get stuck while trying to solve the PySpark question because of the difference in syntax that PySpark coding questions basically have. So without further ado, let's get started with the first question, which says we need to find numbers appearing at least three times, right? Yeah. So the first question says we need to find numbers that appears at least three times in a consecutive manner. At least three times means greater than equal to three. Let's look into our input table. So input table is our numbers table having integer values, and it has all the integer values we need. And if we look into this table, we can see that the correct answer for this table is basically this 4, which is appearing more than three times in a consecutive manner. Now even though these ones are also appearing three times, they are not in consecutive manner, right? Now if we look into same or similar questions, let's start to understand how we can basically think of the correct solution behind this problem. As we can see that it is asking for count, so there will be some group by logic or some aggregation that we need to use. Now, is simple aggregation enough to solve this problem? The answer would be no. Why? Because we need to find consecutive numbers, right? It is not like we need to find total count. If we directly find the total count, even these three ones which are not in consecutive manner will find the count as 3, but we need to find the consecutive numbers only. So this is a standard problem where we need to solve by dividing the problems into certain groups, right? So how to solve this problem? Now before starting to solve this problem, let's give all the numbers a unique identifier so that we are able to basically distinguish every number in themselves inside the table. Now once we have an unique identifier, what can we think of next? Now the main solution, or this is one kind of a pattern where we need to solve the question by dividing the numbers into certain groups. If we are able to divide this one and this one into two different groups, our solution would be complete. So the main reasoning behind the behind solving this problem would be to divide all the numbers in specific buckets. Now this is a standard problem, right, where we need to divide the entire tables into certain groups using something known as window functions. Now if you are an experienced professional or if you are having your SQL interview rounds in the upcoming few days, so the expectation would be you know what window functions are, what are some of the commonly used window functions, which are lag, lead, right? First value, last value, right? Row number. So if you are having your interviews or SQL coding interviews in the upcoming few days, so it is very important that you understand the commonly used window functions, right? Now, once we do that, which of the window functions we are going to use in this problem is lag. Now, why lag? Now, let's try to understand when does a number becomes a part of a new group? A number only becomes a part of the new group if the number appearing before it, that is the number appearing previous to that particular row, is different, right? So if we understand this, we can say that a number or a row becomes part of a new group if the number appearing before it is different. This is the main logic or the entire backbone of the particular problem, right? Now let's create a column having previous values, right? One does not have any previous value, we'll assign -1. For the second one, the previous value is 1. For 2, the previous value is 1. For 1, the previous value is 2. For 3, previous value is 1. For 3, previous value is 3. For 4, previous value is 3. For 4, it's 4. For 4, it's again 1, 4. Now, since we have the previous value column, the next step is to identify the groups. Now, as discussed just now, when does a number becomes part of the new group? When it is not equal to its previous value. Now, before creating the new groups, what we need to understand is it a part of a new group? Is it a part of the new group? If 1 is not equal to -1, if the value is not equal to previous value, then yes, it is a part of the new group. If the current value is equal to the previous value, then no, it is not a part of the new group. It is part of the same previous group. Now, how does this help in like dividing numbers in groups? We'll look into that when we in the next step, right? Now let's try to fill this column, right? Is 2 equal to 1? No. So it's part of the new group. Is 1 equal to 2? No. It's part of the new group. Is 3 equal to 1? No. It's part of the new group. Is 3 equal to 3? Yes. It's part of the same group. Is 4 equal to 3? No. It's part of the new group. It's 4 equal to 4? Yes. If 4 equal to 4? Yes. Now, this is the second last step. Now, once we have identified if they are part of the new group, how we can basically divide them in groups is basically taking the rolling sum of this entire column. Now, let's see what happens if we take the entire sum of all this column, right? So let's take the sum or the rolling sum, right? Or the prefix sum we use in coding interviews. So 1 plus 0 is 1, 2, 3, 4, 4, 5, 5, 5. Now this is exactly what we wanted. Now if we look at our current values, this once is becoming part of this group. The third one is becoming part of the third group. Now this is exactly what we wanted, and this is the exact logic that will help us to solve this problem. Now now you might be thinking that like if we look into this problem for the first time in interview, how do we solve them, right? So this is exactly why I have tried to collect all the questions, all the patterns that are being asked in the interview rounds. And once you look into all the questions, all the 17 questions that we have for today, I can guarantee you that you will look into similar patterns of questions in your interview rounds, right? Now, what is the last step after we have divided into groups? It's a basic aggregation where we do a group by based on the group and the value, or value and the group, and then we say we only want the number having count star greater than equal to 3. Okay, so we have understood how to solve this problem. Now what we will do is try to solve this question first in SQL, and then we'll come to PySpark, right? Okay, so for that, let's move to our online compiler. So this is the GitHub repo that I will be pasting in the description of the video, where you can take the sample input setup, right, that you need to configure in your compiler. If you have a local setup ready with you, well and good. If not, we'll be using a online compiler. For my purpose, I'll be using PostgreSQL. It is a open source framework widely used across multiple organizations. Like multiple big companies are switching to Postgres because it's open source. They don't need to maintain the licensing, and it also provides a lot of benefits. So I'll be using PostgreSQL. If you want, you can use MySQL as well. It provides you with a lot of different options. I'll be pasting the link of the same in the description of the video as well. So we take the setup from this GitHub repo. And then we can see by running a select star from numbers, and we hit the run button to get the output of our numbers table. Now, what was the first step of our solution, right? The first step was to create some type of identifier for our numbers table, and for that we'll be using CTs. Let's name the CTs as ordered, which will give us an order or a distinct identifier for each of the row in our numbers table. So let's say select value and row number. So this is again one window function over as rn from numbers. Now let's see what this gives us, right? So this will give us a unique identifier for each of the value. Row number is 1. We also have dense rank, but for this problem we will be using row number, right? Now once we have that, what was the next step? The next step was to find what is the previous value for each of the row. Now let's create another CT, select value, row number, and for previous value we have a window function called lag, which will basically divide your entire table into windows, and for each row you can find what was the previous value that was appearing before that row. Now on which column do we need the previous value? We need the previous value based on the value or the value column of our table over order by row number, right, as previous value, right, from ordered. Now let's see what output it gives us. Small syntax issue. Okay. Now if we can see, we have got our previous values for each of the row. Now there is one edge case basically where the first row does not have any previous value and it will return a null. Now in that case what we need to use is a coalesce. So coalesce will take the first value from your list of values, and if it returns a null it will basically skip it. Now this particular function for your first row will return null, and in that case we'll be taking -1 for our first row. So if we see, we got -1 for our first row. Okay, now we have reached till the second step of our solution, right? Now next step is to identify that if that row is a part of a new group or that row is a part of the same group, right? Now to do that, let's take select value. Now if you go back to the video and understand what was the logic, if our current value is not equal to its previous value, that means it's forming a new group. If our current value is similar or same to its previous value, then it's part of the same group as the previous row. Let's try to formulate the same logic in here, right? So case when, so for that what we use is basically a case when, right? So case when value is not equal to previous value, right, then assign 1, else assign 0, and as is new group, right, from numbered. Let's see what we get here. Basically let's take a select star here. Yeah, is new group, so the same logic is being applied here. Now once we have a is new group, the next step is to divide them into our required groups. So the required groups here will be as taking the rolling sum, right? So we take the sum and it will basically divide each of the row into its specific group. So required groups will be basically select star comma sum, which is again a window function, and in which column we need to find the sum is new group over order by row number to have the rows coming in the same number or the same order that was in present in the table, right? Order by row number as group from grouped, right? Okay, let's see what output it gives us. We have the groups now. This one and these two ones are part of different groups. Now once we have this, the last remaining steps is basically select value from required groups, group by value and group. Basically first will be group and value having count star greater than equal to 3, right? So we group that this particular table on basis of these groups, and we take only the row which is having more than or at least 3 times in that specific group. So in this table, the group 5 is the only value having more than or at least 3 as its count, right? Let's run this and we have our value in it. So basically this is it for our SQL problem. I can understand that this might seem a bit difficult if you are looking at this problem for the first time. But trust me, these are the type of question that are being asked right now in your SQL interview questions, right? So knowing how to solve this question, having seen these patterns before your interview round is very important. Otherwise, it becomes very difficult to come up with the solution in that specific time frame of the interview. Now let's look into our PySpark solution for the same problem. I'll not be focusing more on the explanation of the same logic again, but we'll be focusing more on the syntax of the commonly used functions in PySpark. So we take the entire setup script from the GitHub repo and we paste it into the compiler. Make sure you have all the imports ready. So mains are pyspark.types, import star, pyspark.sql.function, import everything, and for window function, import the window, right? Now once we have that, it is an online compiler, so paste the setup script and run the code and you should be able to see the data frame available in your online compiler as an output. Once we have that, the first step is to define our window, right? So we say window and on what factors basically what we want to create the window. For this, we'll be using monotonically increasing ID as our order by clause. As PySpark is a distributed framework, we need to give it handle it using monotonically increasing ID. After we have done that, we need to create our ordered data frames. So here the mediocre data CTEs will be playing the same roles as our data frames that we'll be creating here. The CTEs are equivalent to the data frames and the same SQL code that we have solved just now. So we say ordered df and we want to create a new column using the with column function of the data frame API. We give the column name as row number and then we use row number to give distinct identifiers to our each row in the numbers data frame or the numbers table. So we say that orders data frame, we create a new column and we run the code and we should be able to use, I'm sure that's a syntax issue. Yeah. So once we compile the code and we can see it using the display function in the online compiler, and we should be seeing that a row number is assigned to each of the row in the data frame. The next step is to find the previous value, right, based on the row number. For that, we need to again create one more window, and this will be ordered by our row number column that we have just now created. Now, what we do here is use this ordered data frame and then create a new column named previous value, and then we'll be using the lag window function on the value column as our previous value. which will basically give us the previous value for each of the row. It comes up in double brackets. Then once we have that, the next thing is here to identify the edge case of the first row not having our previous value, and in that case we want to assign a -1 value for the first row, right? Okay, seems to be one more syntax issue. Okay, with column, okay, looks like, yeah, so we have the previous value for our first row as well. Once we have that, the next step is, if you remember, it will be identifying if we have if the row belongs to a new group or a previous group. So for that we use a when clause. When this value, right, column value is not equal to the previous value, which is here. So what we say that assign a 1, otherwise assign a 0. So case when statement and the syntax of it is also an important part which might trick you in your interviews if you don't know that. So we say that, and the column name changes to is new group. So once we have that, we should be able to see is it a part of the new group or not. Once we have that, the next step will be to find the grouped df, wherein we'll find the sum of this entire column based on the same window that we defined, right? So we'll take ordered df dot with column, and we'll create a group, and group will be using a sum on is new group column over our window that we have defined just now. So if we try to look at this data frame, so we got our group that is basically required as the second last step. Now once we have that, our final data frame will be just a aggregation on our group df. So group df dot group by our group dot aggregation, and basically not an aggregation count, right? So we want a count based on this grouping. So once we have that, let's see what output we have here, right? So we got all the groups, but we'll also need the value as well. So group and value. So if you remember, we ordered by or grouped by based on the group and value in the previous table. So similar logic applies here. We have the value, we have the count of each value based on the group in our consecutive manner. Once we have that, we only filter out the group having count greater than equal to 3, and we select the value for it. Once we have that, we have our final data frame, and that is it from the first question. We have the SQL and the PySpark interview ready code for our first problem. Now with that, let's look into the second problem of our series. So this problem states that fill the null age values in the employee table with the previous non-null values. What does this mean? If we look into our input employee table, it has columns ID, name, and age. So age are integer values, and we need to fill all the null values with its previous non-null values. What does it mean? So this null value over here has a previous non-null value of 28. So we'll be filling this null value with 28. Similarly, there are two null values in here. What was the previous non-null value before this was basically 24. We fill these two null values with 24. So that is how our output table looks like. Now this comes in the similar pattern of problems that we have just now solved, where we create groups, and based on that groups we try to create the final solution, right? How do we start solving this problem? Now, as it says that we need the previous not null value, it is important for us to divide the rows in certain groups. So the groups should be like that. We have our null values and the previous not null value in the same group, right? So how do we start solving that? So previously, what did we see? We saw that we create a is new group column, right? In the same way, in this problem, we can think of creating a is not null group, right? So where we say that if our age is not null, we assign it 1. If our age is, okay, sorry, it should be in our input table and not in the output table. So we say that if our age is null, not null, then we assign 1. If its age is not null, we assign 1. If it is null, then we assign a 0, right? 1 0 0 1. Now after that, if you remember the previous problem again, I'm saying that because we need to understand the pattern of this problem. So if we have solved the previous problem, we should be able to think of it in the similar way. We created a is not null column, and after that, what did we do? We created a rolling sum, right? A rolling sum, which I will say a group in this case, and then we created the rolling sum of it. 1 2 2 plus 0 is 2, 2 plus 1 is 3, 3 plus 0 is 3, 3 plus 0 is 3, 3 plus 1 is 4. Now what did we do just now? 30 belongs to our first group as it is a not null value. 28 belongs to the second group, right, as it is a not null value. Now coming to this next row, we see that 28 and null are coming into the same group of 2, right? Okay, so once we have that, 24 comes into our third group, but then the following two rows having null values come into our same group, right? So 24 and the next two rows comes into the group 3. How this will help, we'll just see in a bit. Now once we have divided this rows into a specific group, what we can do is again use a window function called first value, right? So first value is again an important window function which is useful in sometimes. Once we have created the group, what we do now is we partition the entire table based on the group. So the partitions will look like the first partition 1 will have the value of 30. The second partition now will have the value of 28 and null. The third partition will have the value of 24 and two null values, right? And the fourth partition will have the value of 31. Once we do that, what do we say that? We want to fill this null value with the first value of each partition. So the first value of each partition will be not null for sure because that is how we have created the window. Once we have done that, we fill this with the first value or the first value window function for this null values. Okay, I hope you guys understand the logic behind this problem. I put this problem after the second problem because it follows a similar pattern. Now once we understand this, let's try to code it down. For that, I'll again move on to my GitHub repo and I'll move to the first question of it, right? So let's move to the first question. Take the setup.py or setup.sql in this case and put it in our online compiler. Make sure the code is running. Yes, we have the code up and running. So what we do now is we create the first CT, right? I like to name it as ordered. as select star and case when. So we want to create the is not null column. Case when is not null, then 1, else 0, and as is not null from employee, right? Let's see if it is working as expected. Yes, we have our is not null column. The second thing that we need to do is to create the rolling sum so that we get our required groups. Grouped data as, so a group data will be select star sum of is not null column over order by our ID column as group from ordered, right? Yes, and then we again look into the data to make sure everything is working fine. We have our group. Then the next thing we need to do is to partition the data in the required groups. So you can basically eliminate few of the cities here, but I want to make it as intuitive as possible. So I'm moving step by step, but as and when you become more comfortable, you can eliminate this middle cities that I'm using and combine both the steps in a single city as well. So the required data will be select star from, and here we'll be taking the first value of the partition as we have just now discussed. So the first value of age, which will be not null for sure, over partition by, will be partitioning by group and order by ID as our age, right, from group data. With that, we should be able to see our required answer, right? Yeah. So we basically only select our ID name because that is what is required in our final answer. And if you see, we have just now solved a tricky problem because we knew the pattern for it of dividing it into groups and then solving or trying to tackle the problem. So with that, we can move on to the Pyspark solution for the same. I again move on to my GitHub repo, take the setup, move on to the compiler, and then paste the same code as it is. Make sure that the code is running fine. Hit on the run button, and yeah, I see something is missing. Okay, yeah. So let's try to run the code. And if you have imported the code correctly, you should be able to see it. Trying to solve the question in the same manner, we first create the window, make sure you have the window imported. Dot order by, in this case, we have our ID column ready with us this time in the input table, so we don't need to create a monotonically increasing order. Once we have the order, we create the order data frame, or I like to take it in the same data frame itself. Dot with column, we name the column is not null. So when we say when age, when column age is null, then we say give it 1 dot, otherwise give it a 0. Once we have that, we say take the rolling sum of it to divide it into required groups. Group dot sum over is new group, right, is new group over. Now here we need to define a different window because we'll be creating a partition by based on the, not here basically. Okay, we can use the same window here. So order by ID, so the rolling sum will be using the same window that we just now created. Okay, window 2 is not defined because we'll be using the same window over here. Okay, not is new group, is not null. Yeah, so we can see that, okay, I think we is not null, right? So it should be if is not null, then we put it as 1. So if the age is not null, we put 1 as the value, else we put 0 as the value on in the is not null column. Once we do that, we take a rolling sum to divide the employee or table into required groups. If you see, 28 falls to that group 2 and none also falls in the group 2. Now we can take the first value of it and assign it to the none so that we get the previous not null value from the employees table. Now the next step here is employees data frame. Data frame is equal to employees data frame dot with column, and we say age, right? New age, right? New age or filled age, we can say filled age as, we say first value of what? Of age of column age over. Now this time we need to use a different window. So different window can be defined as window dot order by, first we let's say partition by what? This new group that we created. So we need to divide the table into partitions based on our group and order by the same ID column. Once we have done that, group by group and order by ID, we'll be using that particular window in our second window function, and using the first value we'll be able to get the filled age. So we get the filled age with null values or the none values replaced with the previous not null value in the table. Then you can just do a select on it and say ID name column filled age dot alias, give it name age, and then you get your required desired output. I hope this was clear and you were able to identify the pattern of dividing it into groups and solving the problem. We have solved the second problem. Now let's move on to the third problem. Let's look into the third problem and try to solve it in both SQL and PySpark. So the problem says find the department with highest average salary, right? And the input table given to us is of the employee table, which has this particular columns: employee ID, name, salary, and department name. So this is relatively easier than what we have solved till now, but this was asked in JP Morgan, so let's try to solve it in this video. So there are departments with engineering, HR, sales, right? And then we need to do grouping of all those salaries and find the average, right? So it will be 550K plus 60K divided by 2 for engineering. For HR, it will be 40K plus 45K divided by 2, and for sales, it would be 70K divided by 1. So if we look in that way, the answer should be sales because it has the highest average salary. Now, this is basically a group by department name, right? And then we need to find the maximum from the average salary by department. So let's try to solve this question first in SQL. For that, I'll again move to my GitHub repo and let's try to find that question. The question is question number 10. Yeah, it is over here. We'll take the table setup first, go to our online compiler, paste it over there, take the input sample data, again paste it over here, and then try to see if our data is imported properly. All good, we are able to see the data. Yeah. So now let's try to create a CT with max average salary as select department name from employee, group by department name, right? And what we want to find here is average of salary as average salary, right? Now what we need to find, select star from employee table, or it will be basically select star from max average salary, where salary, or okay, so this will be average salary only, not max, right? Where average salary is equal to select max of average salary from max average salary. So yeah, this should give us what we are looking for. So yeah, basically this was an easier problem. We created a CT, found the average salary for each department, and the final task was to find the department having the average salary that is equal to max of the salaries from that CT that we created in the step before. Yeah, so let's try to solve the same in Pyspark as well. I'll be taking the same code from the repo, paste it over here, and try to see if the data was imported properly. So for that, display employee data frame, run the code. Yeah, it is imported properly. So the first would be creating a group by employee data frame dot group by department name, right? Yeah, department name dot aggregation of average salary of salary, and we need to give this name as over here dot alias as average salary. Then we need to find the max average salary data frame as employee data frame dot max employee data frame dot aggregation of max of average salary, right? Dot alias as max average salary, right? Now one case here is because we are using PySpark and it's the same max function as in Python. So when importing, we need to import max as underscore max just to distinguish between Python max function and PySpark max function. So we are importing it as max. So yeah, so this will give us the max average salary data frame, but what we need is basically the max salary value. So we need to extract the max average salary value from this data frame, for which we can use the collect function, right? So collect will basically give us the max average salary value instead of the data frame. So once we get this, it is only the matter of fact that we will take the employee data frame, and then what we can do is basically filter out column average salary is equal to max average salary value. If we do that, we get an error because, so again, a mismatch issue, which is basically the mismatch with the column name. So yeah, once we fix that, so because we renamed it to alias max average salary, so we need to use the same when we are trying to collect the value from the data frame. So again, an easier problem, a problem on the easier side. And we have the Pyspark code for that as well. With this, we'll wrap up our third question and move on to the fourth question. So with this, let's get started with our next problem. The next problem says product sales by year, right? So let me select the pen. Yeah. So next problem says product sales by year. We need to write a query for each product that is given by product ID, and we need to find the total sales done in 2024 and 2025. Again, a problem on the easier side, I would say, but the catch here is how you would display the data in this particular format. So in the output, we need product ID, 2024 and 2025 as different columns, right? So this is where there is a bit of catch we need to identify, otherwise we'll not be able to solve this problem. So we need the total sales, and that should be easier to identify. We need to do a group by product ID and here, right? And then we need to find the sum of sales for each product ID. This is one, but since we need to group by here, first we need to again fetch the year from date. So we need to fetch the year from date. Now, how do we represent the sales of this table in two separate columns? Because if we do a simple group by, it would basically put it in a same column and not two different columns. To do that, what we can do, we can create two different CTs, sales A having sales data for 2024 and sales B having data for 2025. Now, once we have that, we can do a join on A and B to get the data for both 2024 and 2025. Now here the important thing to identify is which type of join to use. Let's go through each of them. If we do an inner join, we'll find the data, or we'll find only products which were sold in 2024 and 2025. This is not something that we want. If we do a left join, we'll only see product IDs or products that were sold in 2024. If we do a right join, we'll only find data or products that were sold in 2025. So the correct join that will give us the products that were sold in both 2024 and 2025 is basically this full outer join, which will give us 2024 as well as 2025 data, right? Now that we know this, let's try to solve this question in both SQL and in PySpark. I'll take this and basically I'll import the data, and then let's try to see if everything is working fine. It is. So let's try to create the CTs. Our first CTs will be, for example, year data. Let's name it as year data, and select star and extract year from, so basically extract here from our date column, right, as year, right? Let's name it as year from sales. That's it. So what we'll get here is basically our data along with year column. Let's try to see if it is working as expected. Select star from year data. I missed the from here. Right, so I have the years along with what I need. So now I need now I have the data that can be grouped according to 2024 and 2025. So now let's create a sales ACT having our sales data sales data with only products that were sold in 2024. So for that, I will do a sum on sales as sales 2024 from year data, right? Group by product ID and here. But to filter out the data that were sold in 2024, I need to filter out with year is equal to 2024. So this way we'll be getting only the data that were sold in 2024. Now same needs to be done for sales B to get the data that were sold in 2025. I'll copy the same code, but I'll paste it and make the changes to get the data only for 2025, right? Now we have the data for both 2024 and 2025. The only thing we need to do here is now do a full outer join. Select what do we need. So we'll need the product ID, sales A, sales 2024, sales 2025 from sales A, full outer join, sales B on sales A dot product ID is equal to sales B dot product ID. Now that we have it, so one edge case over here. So since we're using product ID, so does not necessarily mean that that product was basically sold in both year 2024 and 2025. So to handle this, what we need to do is a coalesce, and basically we'll say regardless of it was sold in 2024 or 2025, you need to show the product ID column. You can use a alias over here, but yeah, I skipped that process. Sales B specified more than once. Okay, so sales A, sales B, right? So yeah, I think it is correct. Let's verify it once. For one, it will be 100 and 120. For product ID 2, it is basically 2024. Yeah, looks good. So with this, we are good with the SQL part of the problem. Again, moving ahead to our GitHub repo to copy the setup and paste it for our Pyspark code as well. Let's import the data. Let's see if everything is working fine. Looks good. So with that, let's move on to the solution of this problem. So firstly, we'll need the year column because aggregation needs to be done on the yearly basis. So I'll say with column year as date format. So whenever you are using these functions, just make sure that you are importing star or importing the specific function in your import section, right? So column, it would be year, right? So with this, we'll get our year column in the data. Yeah, we have the year column. Once we have that, let's do a sales A, which is basically an aggregation on sales TF dot group by product ID. Basically, first we need to filter as well, right? Dot filter year is equal to 2024, right? Year is equal to 2024, and then we need to group by the data. Group by product ID, right? Group by product ID dot aggregation of sum over what? Column salary dot alias as sales 2024. We need to do the same for sales B as well, which will having the data for 2025, and we'll name it as sales B. Okay, so with this we have both our sales A and sales B. Now we need to find our final data frame, which will basically an outer join on both sales A and sales B. So we say join and we give an alias over here, right? So this is also an important syntax so that we can distinguish between both the columns in both the first data frame and the second data frame. And then we say sales B dot alias B, right? Join on condition, join on condition A dot product ID is equal to column B dot product ID, right? What type of join? We'll say full outer join over here, right? So the type is full outer. So once we have this, we'll get the data that is present in both year A and year B. Let's try to see what we are getting over here right now. So we're getting a big fat error. So we have used a wrong name, which is sales over here, right? Yeah, my bad. So yeah, we get the sales for both 2024 and 2025. But unlike the SQL output, we are not seeing the column or the product ID 5. Why? Because it was only used in 2025, right? So we need to handle this case like we did in SQL using qualis. So we'll say select qualis of A dot product ID and B dot. That's why aliases are important, because it helps us to basically smoothen the process or distinguish between both the data frames, right? And then we'll say sales A. Okay, so yeah, so I think that should be fine. No, we need also sales 2024 and sales 2025. I think, yeah, this should be good. So we have our 5 as well. So with this, we have the Pyspark code as well. The catch was to divide it into two data frames and two CTs in sequels, and then to use full outer join to get the data in both 2024 and 2025, and then to use a coalesce as well to handle that edge case. So with this, we are done with this question. Let's move on to the next question. This one is an interesting problem asked to me in a startup of mine, right? Just a few weeks back. So it's a school food distribution system. So it's a bigger problem, right? You need to find what you need to solve in this problem. So you need to do the distribution for a few schools in the city. The kitchen prepares 100 kg of food every day, and the food has to be divided among the schools according to the number of students in the school. And the school further divides or distributes the food according to the weight of each student. So there is a single students table which will have the school name, student name, weight of each student. Let's consider the school names as A and B, right? And let's say there are two students in school A and one student in school B. So the question says that each day the kitchen prepares 100 kgs of food that needs to be distributed to school A and school B, right? School A has two students and school B has one student. The weight of student 1 in school A is 30 kg, a bit less, right? I would say. And the weight of student 2 in school A is 60 kgs. Similarly, school B has only one student and the weight of the student is 70 kg, right? So first of all, the distribution will happen based on the number of students, which says that if there are two students in school A and there are a total of 3 students, school A would get a total of 200 divided by 3, which will be 66.66 kgs. At the same time, since B has only one student out of 3, so school B would be getting 33.33 kgs. Now, even after this, in school A, there will be distribution based on the number or the weight of the students, right? So since the weight of student 1 is 30 kg out of 90 and it will be 66.66, so the output we'll be getting here is, let's solve, right? So the output that we'll be getting here is something wrong over here, right? 1 by 3 into 2.22 kgs. So this is not right. It's 2.22 kgs, right? Yeah. At the same time, since student 2 in school A weighs more than student 1, he will be getting a total of 2 by 3. So, right? So we will get 44.45 kgs. And since there is only one student in school B, right? So this will be basically student 2 and student 1. In school B, there is only one student, so he'll get the entire share of 33.33 kgs. So if we try to formulate the formula of the entire distribution, what will be the formula? It will be basically 100. First, its school will get, so 100 into students, count of students by school, right? Count of students by school divided by total students across all schools into weight of the student divided by total weight of the students by school. Yeah, so now that we have the formula, rest of it would be easy, right? So main part here was to formulate the solution before you even try to code it down, because in an interview you'll be in pressure, so you need to solve the question in an organized way. So what things do we need? We need the total count across schools. We need the, so we have this one, we need the total count schools, total count of schools, right? Total count of students, I would say. So total count of students by schools, right? So we have this, we already have this. Then we again need total weight of students by school. So how do you solve this? With this input data will basically help you to solve this question. So what do we need? We need the total students. So how do we get that? So we'll again use a window function called count. Count will basically help us to solve this question to get the entire count over null, you can say, right? Count over null will basically give us the total count of the students. Then we need, there is less space over here, so let's try to create the same table again. A, B, S1, S2, S3, 30, 60, 70, right? So this is the input table. We have the total count of the student, which will be basically count over null. Now, how do you get the sum of the weight? So basically that would be an easy one. Sum of weight, right? Sum of weight over partition by school name, right? Why? Because let's say we partition by A, where our first partition is this one, and partition by school name, and our second partition is this one. What we need is basically sum over both these partitions to get the total weight of partition by school. The third thing we want is what is the count of student in each school. So that would basically be equal to count of star. So basically in this partition what we need is a count star over here, right? So it would be count star over partition by school name. So once we have this in a CT, so we'll create a CT where we'll try to formulate all these three things, and once we have that, we should be able to get the answer with our formula. Yep. So this was it from the logic side. Let's try to code it down in SQL and PySpark. Okay, so that will be question 3. Let's take the setup and put it over here. So let's say with I would like to name it as ordered data as. First thing is select, so let's say student name, or let's select everything from here. And the next thing would be count star over what? Over null values to get the total count of students as total students count star over partition by school name as total students by school. We have this. Next is sum of weight, right? Sum of weights over, again, partition by school name. So as total weight by school, right? From students table, let's see what we have now. Yes, we have it. Total number of students is 3. School A has 2 students. School B has 1. Total weight of school A is 90. So we have everything we need, right? So now we just need to use the formula that we formulated over in the explanation section. So we'll take school name, we'll take the student name, and we'll use our formula. So formula was like this: 100.00 into. So I would go back to my formula. The formula says students by school. So total students by school divided by total students, right? So that would give me the distribution for each school, and even in that school it would be basically weight divided by our total weight by school. Once you have that as division or distribution, let's say, from ordered data, let's try to run it. We have what was asked, right? And that matches with our sample output as well. This was basically the SQL part of it. Now let's again move back to our GitHub repo to get the Pyspark setup script. Paste it over here and try to query it, right? We have what we need. So let's try to solve it down. Basically, we'll need two windows. Make sure you import the window function. So first window would be over null, so the entire table to get the count of the all the students, right? Second would be partitioning by our school name to get the aggregates based on each school. So what we'll do first is to find the count, right? So I'd say with column students df with column total students, and that would be basically count star over window 1, right? And let's see what we get. A typo over here, again a typo over here. Yes, so we get the total students, which is 3 over here. Now we need to find the next needed details, which is the total weight by students and the total students per school. So let's try to find the first one, total students by school, which is basically count star, but this would be partitioned by school name, so we'll be using window 2. Then the second thing we need is total weight by school, which would be basically sum of weight over window 2. So let's see what we have. Weight is not defined. Should be, because I have not used double quotes over there. We have what we need to be used in our formula. So what we will do now is students df is equal to students df dot width column. What we need is distribution as what would be the formula. So it would be 100.00 into the formula says students by school into weight divided by total students into total weight by school. So we need to use here column function. Let's give it a try. So yeah, so we have what we need, so we can also filter out based on the details that will be needed in the output table, so which would be school name, student name, and distribution. Great. So with this we come to an end of question number 5, and we'll be looking into question number 6, which is again a very interesting problem and it will challenge you a bit. Now let's solve this problem, tiered reward system analysis. So this is one of my favorites, and this question really impressed me that to what level the interviewers can go when it comes to a question. This is a very long problem, and to find out what you need to solve is very important when it comes to this long problems having multiple tables with a lot of different columns, right? So this problem says that write a SQL query to identify users who qualify for a tiered reward system, and there are certain specification based on the rewards to be given that we'll see in the bottom of the question. The system is based on both frequency of logins and the amount spent within the last 30 days. The question comprises of users table, activity logs table, transactions table, right? And the sample data has also been provided. So what you need to find as a part of this problem is divide the users based on bronze, silver, and gold. And there are certain specifications given for this tiered reward system. The users who log in the last 30 days more than 5 times or at least 5 times and spent over $100 qualify as bronze. Logins at least 10 times and spent over 500 are silver members. Logins at least 20 times and spends over 1000 are gold members. And finally, you also need to order the final output by tier, so gold, silver, and bronze, and then the username, right? So this is one of my favorite problems, and this actually tests you a lot that how you can approach a problem and how you solve that particular problem. So let's see, right? So first of all, what do we need? So first of all, we should think of like we need to filter out the tables with only the data that we actually need. So there can be a lot of data in the users table, but we only need the last 30 days data, right? Also, there can be a lot of data in the activity logs, but we only need the last 30 days data. Similarly, for here as well, we'll need the last 30 days data. So how do we filter it out? We write a where clause and then we filter out based on the current date minus an interval of 30 days, right? So that will give us the data that we need. This is not that important because this is the registration date and we are not much bothered about the registration, when did the user registered. But the most important part when it need to filter out is based on the activity logs and the transactions, right? It says that we need to count somehow the login counts in this period, as well as the sum of amount spent in the last 30 days, right? So with this, what we can do, we can divide the problem into multiple sections, right? So firstly, what do we need? Firstly, we need the count in the last 30 days. So we can say that activity metrics. So we'll create one CTE with activity metrics having last 30 days data where we'll count the login, right? Then we have transaction metrics, right? In the last 30 days data, we filter it out and we do a sum on the amount. And as finally, we need the user names, right? We don't need the user IDs. Then we need to do some kind of joins here to filter out that particular data, right? Where we have the usernames along with those metrics. And finally, do a case when system. So we create the tiered system, right? Where we divide the users in gold, silver, bronze. And finally, write a select statement, and do the order by as well. So here the order by statement is also a bit tricky. It's not a simple order by. We need to order by it based on gold first, silver second, and then bronze. And if there is a tie, username comes in as the next attribute, right? So looks like a simple problem, but there are multiple problems that needs to be solved. So we need to go step by step and make sure we do not make any mistake in each of the step, right? So we have the logic. Now let's go to solve the problem, and for that I'll move to my GitHub repo. So I am into my GitHub repo now. I take the setup script along with the create table statements and the insert statements, and then I put it to my compiler. For some reason I'll have lost it, so let's just open it now, right? Okay, so we put our create statements and we start solving the problem. It's a bigger problem, so I hope you'll be able to see it. So what is the first thing that we need to do? We need to create the CT to track the activity metrics. How do we do that? With activity metrics as, so what we need, select star from the table is activity logs, where activity date is greater than equal to current date or current timestamp minus interval of 30 day, right? We do it, but what do we need basically is the count, right? So we group by user ID, and we also group by the activity type. Actually, we don't need the activity type, so we'll take the count here, select count star, and by user ID, right, count star as login counts. So we get it over here, and let's try to see if it is working fine. So we need to write it in this way. Okay, so it's not a function we write, so it's basically a syntax issue. So we got the activity metrics, and in the similar way we also need to find the transaction metrics as well, because there are two factors basically. Based on the login counts, they will be given rewards, and also if they have spent more than a specific amount, also they will be given some rewards as well. So transaction metrics as select user ID comma sum of amount spent as total amount from transactions where activity date or transaction date is greater than equal to the same thing, current timestamp minus interval of 30 days, group by user ID. So we get the metrics based on our transaction table as well. So we test it by doing a select star from transaction metrics. Let's see if everything is working fine. Yes, it is. So now we move on to our third CT, which is basically this metrics joined with the user table, because the final output needs to be along with the user names. So we create joins basically on the user table. So with user metrics as select user ID, or basically let's say select star from users as you left join, because we want the metrics to be expressed across all the users. So we say a left join on users. We'll join it with activity metrics on as a on u dot user ID is equal to a dot user ID. Left join on transactions, transaction metrics, right? As t on t dot user ID, or basically first u dot user ID equal to t dot user ID, right? So what all do we need? We need the user ID. We need the a dot login counts, right? We need the t dot total amount, right? So this is all we need from this inner join table. Now let's see if we are getting those or not. We'll also need u dot username, right? And these are all the things that we need. So we see that Alice has logged in 7 times with a total spend of 350. And same for Bob, Charlie, Diana, and Eve. So the next part now comes to creating the tiered system. So with tiered metrics as what do we need now? So we say select username, right? Let's take user ID as well, username. Then comes our case statements, case when. So now is a tricky part that you need to know when dealing with case when statements, right? So it says if there are logins that are more than 20 times and spend more than $1,000, then it's a gold member, right? But if you put the bronze case when statement first, then that would also mean that if a person is logging more than 20 times, then obviously that person has logged in more than 5 times as well. So when you are making the tiered system, it's the common practice to put, or the right practice to put the gold layer first, so that only the users qualifying with gold will enter that. If not, then they will come to silver. If not, they will come to bronze, right? So that is the correct way of doing that. So we say that if login counts is greater than equal to 5 or 20, right? Because we are writing for gold, 20, and total amount is greater than equal to 1000, then gold. When login counts is greater than equal to, for silver it is 10, and total amount spent is greater than equal to 500, then it's a silver. When login counts is greater than equal to 5 and total spend is greater than equal to 100, then it's a bronze, else null. And we end the statement as our tier. From where? From user metrics. Once we have that, we have everything that we need. Then we do a final select statement from user ID, username, and right, and tier from tiered metrics. Now what do we need finally? Where tier is not null, so we only want to find the users that are in our tiered system, and order by, case when. So this is the tricky part which you need to know. So when you say you need to order by based on the gold, silver, and bronze, this is the way you need to write the SQL. So basically, this is the syntax. So this is something related to the syntax side that you need to know. When tier is gold, we say it's 1. When tier is silver, we say it's as 2, right? When tier is bronze, we say it as 3, and then basically we end the order by statement. The second attribute we can order by is username. So this was the requirement that was given. Basically, I'm not creating it up. So if it needs to be ordered by based on gold, silver, bronze, this is the syntax you need to follow. And finally, we have the username, right? So this sums up the entire problem. As you can see, this is a very long problem, but it is not something that we cannot solve, right? This consists of multiple small problems, and it tests you basically how you can put all the entire problem together in that time frame of the interview, right? So yeah, if we even see the test data, only Alice has qualified as a tiered user, and he is a bronze user for now. So this sums up how we solve our question in SQL. Now let's go back to our GitHub repo and take up the setup for our PySpark question. So I'll paste this up, right? So I'll paste this up here, and then let's try to query one of the data frames to see if everything is working fine. It is, right? So let's solve this problem step by step. Again, we need to create the activity matrix df. So activity matrix df equal to transaction or activity transaction, right? What is the name of the data frame? It's activity logs data frame. Activity logs data frame dot with column, or first basically we need to filter by, right? So we need to filter by records where the current date is basically greater than, the activity date is greater than the last 30 days data, right? So how do we do that? We do that by using a filter clause, right? Where we say column activity date should be greater than equal to, greater than equal to date subtraction of current date minus 30. So these are some of the common, I would say, date functions that becomes important in the interview. And I would also like to say that if you are not sure, you can also write the pseudocode for it. Basically, you need to explain what you are thinking, and your thinking should go through to the interviewer, even if you don't know the syntax at that time, right? So this is the correct syntax for it. So we say that our activity date should be greater than equal to the current date minus subtracted by 30 days, right? Then what we do a group by our user id, and then we do a count, and this will basically give us the total counts. And if we want to maintain the same column naming as we did in the SQL, we'll just rename the count column with login counts, right? We got our activity metrics. Let's see if that is working fine. It is. So we get the username or the user ID and their login counts. Now we need the transaction matrix df, which will be transactions df dot filter. We have here transaction date should be greater than or equal to date subtraction of current date minus 30, right? And then we do a group by user ID. We do a aggregation of sum of the amount this time, right? What we want is the sum of total amount spent, which is a column name of amount. We give it a alias of total amount, right? And then we get what we need. So let's try to query this table or data frame as well. We have it. Now the next thing here comes up for our user metrics df. How do we do that? So basically it will be a join on the user's data frame, which is users df dot join transaction df first. I'd also like to give them an alias of u and transactions df dot alias as t. Right, what we need is basically a left join on u dot user id is equal to column t dot user id. What type of join? It's basically a left join, right? Then what we do is do a join on activity metrics df. I give it an alias of a, do a join on u dot user id is equal to column a dot user id, and then I think we have the user metrics data frame as well. Let's try to query it. User df is not defined, so it is named as users df, so we'll have to use users df here. Yeah, so we have what we need. Now the final step comes down to creating our tiered system, right? So I'll call this as final data frame, and it will be basically user metrics df dot with column. We need to create a tier column, right? And we say when tier or when column, we need to put it inside brackets because that is the right practice to do it. When you have two or more conditions you need to match, you need to use a bracket here. So column login counts when it is greater than equal to 20, and we use the second bracket column total amount is greater than equal to, what was it, 1000. Then we say give it a 1, right? Not here but here. Are we using the right syntax? Yes, I hope so. So it's not a 1, it's basically a gold member, right? We have this. Then second we say is the width column, right? So we give a width when, again the same thing. So I'll copy it from here, copy the entire thing from here and put it here. Login counts basically is greater than 10, 500, then it's a silver. Again coming down when login count is greater than 5, I think, right? It's 5, and it should be, I think, 100, then it's a bronze, right? Okay, so I think I missed the when here, right? Yeah. Okay, so there is also a missing bracket here. So let's rewrite this 8. Let's rewrite this as 5, and here adds 100. It becomes a bronze member, right? And now finally coming, otherwise it's a null. Where did we lose our, okay, we lost our width column, we'll add it, otherwise a none. right? Okay, making sure the braces are correct, right? Okay, so let's see if our syntax is correct, because there are a lot of braces happening. Okay, found out the problem. So basically the joins we were doing were in wrong data frames. So we basically had to do the joins in the activity matrix DF and transaction matrix DF and not the original source tables, right? So let's fix that. Transaction matrix DF and activity matrix DF is correct. Okay, now we have what we need, right? Total amount, we have it here. Now it should be correct. Let's see. Code executed correctly. Okay, so we have our final DF ready. Finally, what do we need to do is basically do an order by on this data frame. So final df dot order by, similar to what we have solved before, we need to understand the syntax for it. Syntax goes like when column tier is equal to gold, right? Gold, then 1 dot when column tier is equal to silver, it's 2 dot when column tier is equal to bronze, it's 3. Secondly, what we need to order by is with column username. So we have our final data frame, and I hope it's correct. So we do a display on our final data frame and filter it with not null values. So you can do it, filter column tier is not null, right? So this is an important problem which basically tests you in how you can break a larger problem into smaller problems and then solve it. With this, we have covered this problem, and then we are good to go with our next SQL and PySpark interview question. So let's look at the next problem we have for today. So it says highest selling item on a given date. This is the simplest of the question we have in the entire series today. So it has given an orders table as an input, right? And it also has an order details table. What we need to find is basically the product name which has done the highest number of sales in a given date. The given date we can assume is 1st of January 2025, right? So it is a very simple problem, so I'm not thinking of solving the entire problem. I'll give you the logic how to solve it. Firstly, you join the tables, orders and order details table, right, on what to say your IDs. The IDs are basically the same in both, on orders.id equal to order details.id, right? You do that and you do a where clause, right? You do a where clause where date is equal to 1st of January 2025, and then you do an aggregation and find the maximum So this is a very simple problem, so I will give this as a homework to you guys to practice on your own. If you face any difficulties, just let me know in the comments and I'll take this question up, but for now I'm skipping those questions, skipping this question basically. And with this we can move on the next question. So the question we have now is the SQL join types analysis, right? And when it comes to the interviewer, it is one of the most commonly asked question that you can expect in your SQL and PySpark coding interview rounds. This is not the main problem they will be planning to ask you, but this acts as a warm-up problem, right? Because this is a basic problem that if you know, you can solve it in 5 to 10 minutes. And the interview can take up the rest of the time to ask you a bit difficult problem. But if you are not able to solve this problem, then it becomes a red flag just in the starting of the interview only, right? So you will be given two tables, table A and table B, and you need to write the output for left join, right join, inner join, full outer join, and cross join. Basically, this will help the interviewer understand whether you know the basics about joins and how they work or not in SQL, right? And same holds for PySpark as well. So we have two tables over here, and let's write the values for the two tables. Table A having values 1, 1, null, null, 2, 3, 4, and table B having values as 2, 1, 2, 2, 1, 2, null and 3, null and 3. So the first subsection of this problem is to count the inner join. How does the inner join table will look like? So let's try to solve the inner join first. Inner join. So you need to write the output for inner join, and you will not be provided with any editor in this case, and you need to, with your understanding of joins, you need to write the output of this problem. So for this problem, what you need to do is basically you need to find the count of each of the digit in the table A and table B. So table A has how many ones? So we'll take the digit. So the digit and the count. 1 appears 2 times in table A, right? 2 appears 1 time in table A. 3 appears 1 time in table A, and 4 appears 1 time in table A. Nulls are 2 times, right? Similarly, value and count in table B. 1 appears 1 time, 2 appears 2 times, 3 appears 1 time. There is one null value as well. Now, when it comes to joins, the values basically multiply. Since 1 is present 2 times over here and 1 is present 1 time in table B, so we can expect that A inner join B will have 1 into 2. So the count of ones in inner joint A and inner joint B would be 2. So let's have the table, output table, right? So how will our output table look like? It will have 1, 2 times 1, right? So how we can represent this is basically A value and B value, right? So ones will be present how many times? 2 times. 2 will be present how many times? 2 times, because 2 is present 1 time over here and 2 times over here. So 2 will be present 2 times, right? How many times will 3 be present? 3 will be present 1 time. So this is how our inner join table will look like. Basically, the matching values will multiply. One important fact to remember here, inner join does not consider nulls. So even if there are nulls in both the tables, it will not consider them in the output when it comes to inner join table, right? Now let's look into the next one, which will be the left join. Left join. So left join in the sense A left join B. So in this case, we'll get all the values that are present in A, and then we need to match the same in the B table as well, right? So what does this mean? So 1, there are present 2 times, so 1 will be coming 2 times. So let's take the same A value, B value. 1 will be coming 2 times, and same value would be coming here as well. 2, as it is present 1 time, but since it's a match, it will match with both the 2's in table B. So 2 will be present 2 times, same here. 3 will be present 1 time only. Now here is where our value basically changes. Because we are doing a left join, we need to consider each value that is appearing in table A, regardless of whether it appears in table B or not. So we'll have 4 here and we'll have null over here, right? And since there are 2 nulls present, unlike inner join, left join will consider this null as well. So this is how our output will look like for left join, right? Let's see how much space we have over here. Not much. So I'll be moving on to the right part of the sheet. Yeah. So let's do a right join, right? Let's see how our right join will look like. So we are talking here of right join, right? Which means A right join B, right? How does our right join looks like? Now it will consider all the values present in B regardless of whether it is present in A or not. But matching values will still multiply. So in B, what is the count? 1 time, 2 1 appears 2 times, so 2 will be here, right? Similarly for 2, right? Because 2 is appearing 2 times here, 1 times over there. Similarly for 3, 1 into 1 is 1. But here, the only difference will be null will be appearing 1 times, right? Because it appears 1 time over here and it will be appearing 1 time in the right join, right? Now what is next? The next is full outer join. Basically outer join will be an union of left join and right join. So let's see how does outer join looks like. So A outer join B, again A value B value. Basically it will consist of both 1 1 2 2 2 2, right? 3 3, right? 4 null, and also the null values as well. So the 2 null values, right? This is how the outer join will look like. Now finally coming to the cross join, right? Cross join, you will not be able to show to the interviewer what does the output look like because it will be a large output, right? So what you can show basically is how does the output might look like. It is basically the count of integers in A into count of integers in B. So there are 1 2 3 4 5 6 7 7 into 1 2 3 4 5 into 5, 35 values, where basically one will match with this, and similarly for all the ones it will match with this. So each value in A will match with all the values in B and it will be a cross join. Now one question which comes as a follow-up question is, let me write it over here. How does outer join, full outer join differs with a cross join, right? Now if you haven't worked with cross join and don't understand what a cross join is, it might trick you. Basically outer join will match values from A and B. So it's basically a join which is dependent on like values in A and values in B. So if there are matching values, then both A value and B value will have same values in both the columns, right? And it's a union of left join and right join, right? But cross join, regardless of matching or not, each value in table A will match with all the values in table B. So this is how this two type of join differs. This was all about this question. Now next we have a very interesting problem. So this was this, if you can track it in the difficulty level, I would say that this is the second most difficult question in this entire problem set that we have. So let's start to solve this problem. The name of the problem is order status time analysis, and the question asks for query to track order status change over time. For each order, show the duration of each status by calculating the start time and end time for each status period. We have a single table of order events having the event ID, order ID, status, and event time. So let's look at one of the order ID, which will be 1. So what we see for 1 is 1 was open on T1, 1 was again open on T2, which is this one. 1 was on pending on T3, which is this one. 1 was again opened on T4, and 1 was finally closed on T5. So how will the output look for T1, which will basically help us to understand for all the time, all the order IDs, how it will look like. So 1 should be open from T1 to T3, basically the time at which its status changed. 1 was pending from T3 to T4, after which it was again opened. Then 1 was again opened on T4 till T5. Finally, 1 was closed from T5, and if there is no further change, we need to put here current time. Right? So this is how the problem will basically look like, and how to solve this problem is basically, if I would tell you that we have solved a similar problem before, where we need to find the consecutive numbers, right? So if you remember, we found how we can separate these two ones and these two ones in different groups, right? Try to remember. So this falls under the same pattern. So as I have already mentioned that there are certain patterns which keeps on repeating. This is one of those, right? So what we did there, we need to follow the same in this problem as well. We'll try to somehow put this open and put this open into different groups, and we'll put the statuses inside different groups and find the minimum from each of the group as our starting time, right? So let's see how we can solve this particular problem, and basically the rest of the order IDs will follow the same pattern. So what we need to try is to put this open, first open, and the second open, and the pending, and this into different groups. So what we can start off is by putting the change for all these ones. How many ones are there? 1, 2, 3, 4, 5. Okay. We'll put here open, open, pending, open, closed. So when does a number becomes part of a new group? That only happens when the row or the value here is not matching with its previous value. For example, this one and this one will fall into different groups because the current value is not matching with the previous value. Now let's create a column called isChange. And what do we do over here? If our current value is matching with the previous value, then yes, it's a change, right? Okay. So what do we do over here? Did I do the opposite of what I wanted to do? Okay, right. So is new group basically, right? So is new group or is change. If the values of current row and the previous row are matching, we'll put it as 0. Sorry, my bad. And if they are not matching, basically they form a new group. So this open and pending are not matching, we put it under new group. Close and open are non-matching, we put it under a new group. And this open and open are basically matching. So this open, as we saw in the first problem as well, for the first row we put it -1 over there, but for each change we'll put it as 1. Now once we do that, what we need to do for the next part is to create a group, which we do by creating a rolling sum. 1, 1 plus 0 is 1, 1 plus 1 is 2, 3 and 4. So we separated these two ones in one single group, and rest of the parts are again divided into different groups respectively. Once we have done that, the next step will be to create a minimum from this time, right? So from this particular group, if we do a group by, then what will be the starting time basically? So the times here, or the event times, are T1, T2, T3, T4 and T5. So for each group we need to find the minimum time as the starting time. So what we need to do next is to find the start time, right? And we need to create one CT over there. So what we will find here is one open, and rest of the things will be follow, and for here we'll take the minimum time from the group. And since this group is done, next is pending. So minimum time from T1 and T2, and pending will be basically the same time as it has only one value. Again open will have T3, and again closed will have, okay, so this is basically T3 and this is T4 over here and this is T5. Now once we have done this, what is the next step that we need to follow is basically find a lead over the same, right? So we need to do the lead over the values, and we need to use a window function, right? So we create a partition. So we create a partition on the order ID. After we have done that, we create a partition over an order ID, and for each row we take what is the lead value. Now since we have already deduplicated the data, the lead value would be the value in which the status is basically changing. So once we take the lead value, our starting time would be T1, because T1 was the minimum from T1 and T2, and the lead value would be basically T3, and pending will be coming from T3, lead of that particular row is T4, close will be again coming from T4, right? Okay, so again, not this one, it again went to an open state. From pending it went to an open state, which is T4 to T5, and finally it went from T5 to current date. So this is how we solve this problem step by step. So first what we do, we create a is change column. If the current value is not matching with the previous value, we put it 1 and 0. Then we take a rolling sum to divide that into groups, right? We then create a group by, and then find the minimum time from that group to find the starting time. This basically gives us the start time. After we have done the group by logic to find the minimum start time, and we have deduplicated the data, then we partition the data and then find the start time and the end time using the lead window function, right? So this is how we solve this problem. So I hope this is clear, and we can start off by solving this question in our online compiler. say when status is not equal to lag of status over partition by basically order ID, right? Order ID, order by event ID, right? Order by event ID, or we need to handle the edge case as well, which is our first row, or when lag of status over partition by order ID, order by event ID is null, then we say that it's a part of the new group, else 0 and as is change from order events, order by order ID, and event type, right? Select star from changed events. Let's see what is the data we are getting. So yeah, we get order ID, right? Open, open, pending, and again open and again closed, right? Now we need to create the ordered events, right, where we take the rolling sum. So ordered events as select star and sum of exchange over partition by order ID, order by event ID as group from changed events, right? And basically again order by order ID. This is not required in the actual setup, but just to make it more clear for all the people looking into this video, I am putting an order by statement as well. So we got it that this all two ones are coming in different group, and this one with open status is coming in a different group, right? Now let's group this and find the minimum starting time as discussed in the explanation. So select star, not star, here we'll have order ID, right? And then we need to find the status, and then we need to find the minimum, and the group as well is needed, and then we need to find the minimum of event time, minimum of event time as start time, let's say, right, as start time, or basically the event time only, but it will be deduplicated with start time from ordered events, group by order ID, or basically group order ID and status, right? And let's put an order by here as well. Let's try to see how does it look. Okay, so one is opening here, so we are in the second last step. So finally what we need to do is basically use the lead function to get the time where it is changing. Okay. Lead of what? Event time over order by firstly partition by order ID, order by event ID as change or change time, right, from this one. So I'll get one more column, event ID does not exist, right? So why does event ID does not exist over here? Okay, okay, so we can do here event time, right? So this is how it will look like. Now one edge case we are missing is basically the null value, where the last status that it changed does not have any change time in its lead, and I guess you will by now should be able to the second highest salary, and he was basically more of looking into a simpler solution wherein I use a where clause and try to make it optimized using where clause, because when you come to window functions you are basically ordering it, so the time complexity comes to n log n, where n is basically your number of rows in the table. He wanted me to solve in a n complexity manner. So how we can do that is you create a CTE, with having maximum salary value, and you do a select statement and say that I want a star, but where salary not in, you do a select, like basically select maxi from city, right? So this is the pseudocode for it. I hope you guys understand. Nothing much difficult about it, but it is just that you might also need to use subqueries instead of window functions, because window functions are costly in terms of computation. So thinking about subqueries in cases where you are asked to find the second highest might also be useful sometimes, right? This is question number 9 over here, right? So let's go to our GitHub repo and then take the question number 9. Okay, let's take the table setup. Let's see if our import data is successful. It is. So the first step is with max salary as select max of salary, and select max of salary as maxi from employee, right? You have the maximum value. Next you need to do a select salary from basically the employee table, where salary is not equal to select maxi from max salary. So basically this should return you the typo. Basically it should return you the second highest salary, right? Right, and basically it is returning all the values, but we don't need all the values, we need the max of it, because once you say that we don't want the max value from this CT, you are left with all the other values, right? But from all the other values, if you find the max again, you get the second highest value. So it will be 2 into n time complexity, and it basically reduces it to a n time complexity solution. Yeah. So sometimes these are also some tricks and tweaks that we might need to use when finding max salary, which is more computation efficient than something as a window function. So with this, we have covered most of the question. We still have a few questions, and let's try to solve them now. Let's look into this question which says consecutive monthly activity analysis. This is again a very interesting problem which asks you to identify the users which have been active on the platform for at least 3 times in a month, and they have done this for 6 such consecutive calendar months, right? So we'll be given a user activity table. I have taken a subset of the data, and from the data you need to find the users who have logged in at least 3 times in a month, and they have been doing that for 6 consecutive calendar months. There are two smaller problems in this particular problem. First problem is to find users who have logged in greater than equal to 3 times in a month. Now how do we do that? That is basically very simple. If we are able to truncate the data, that is 2024-01-05, if we are able to convert this into 2024-01-06, 01 and do the same for 2024 0112 to 2024 0101. Then we can directly find a group by using this particular month, and then for that user we can simply find the users who have logged in more than 3 times. So this is the first problem, and that can be solved by using a date trunc function. Date trunc function in Postgres, right, where we say how much we want to truncate the data, and we'll say month. And then secondly, using group by clause. This solves the first part of the problem. Now, how do we solve the second part of the problem, which says consecutive months for 6 times, right? Now, as we have already discussed and have already seen, consecutive, when we hear the word consecutive, we should be thinking towards window functions. Now we have seen the first pattern of this problem where we take the previous value, current value, and try to form a groups. Now this is the second pattern of the similar question which asks you to solve consecutive numbers, and wherein we subtract some value from the current value to form our groups. Now let's try to understand that with the help of an example. So if we take this value 2024-05-01, 2024-05 or 06-01, 2024-07-01, 2024-08-01, 2024-10-01, 2024-12-01. I have taken 1 because we have truncated the data in a monthly manner, so it will truncate the days to 01. Now, if we give a row number, right, ordered by the dates, then what we will get? And for some time, let's assume that these row numbers are basically in months, right? So what will happen if I subtract 1 month from this particular date? What value will I get? The value I will get is basically 2024-04-01, 2024. So 2 months from this particular date we'll get 0401. 3 months from this date we'll get 2024-04-01. 4 months from this date 2024-04-01. 5 months from this date 24-05-01. 6 months from this date 2024-06-01. Now you can see what I'm trying to do. If the numbers or if the dates are consecutive, and if we subtract 1 month, why 1 month? Because we want the monthly aggregate of the data. So we subtract 1 month, and you can see that it has beautifully created this group wherein these months were consecutive. Now I have taken here how many? 4 groups, like 4 dates, but similar holds true for 6 months as well. So what we will do is we'll subtract this months or increasing values of months from these dates, and we'll create the groups, and then what we'll do is do a group by and find the months having count of greater than equal to 6. So this is the basically the entire logic. Firstly, we'll find the group by, do the date trunc, and then find at least 3 times. And secondly, we will be subtracting 1 month from this date by giving them the row numbers ordered by the dates, and then we'll form the groups, the required groups, and then we will find the users who have been active for 6 consecutive months. This was the logic for the entire problem. Now let's try to code it up in our online compiler. So let's move on to our GitHub repo and then take the setup script and then paste it over here. Let's try to see if our import is successful. So the data load was successful. Now what we do first, as we have already discussed, we'll create a CTE named monthly user activity, where you will be using a date trunc functionality to truncate the data into months, right? Select star and date trunc. What will truncate by month and activity date as month from user activity, and let's do a select star from monthly user activity, limit 5, just to not burden the compiler. Yes, we have it, you see. 05 is truncated to this one, right? And it's basically coming as a timestamp. We need to convert it to a date. So we typecast it to a date format, and what we get is exactly what we need. Now, after this, what we need is the second part, or the first smaller problem of this bigger problem. We'll find users that have logged in for at least 3 times in a month. Select user ID, month, from month user activity, group by user ID, month, having count star greater than equal to 3. So with this, we found the user that have logged in more than 3 times in a particular month. Okay, now this comes to our second problem, wherein we will be assigning the row numbers to each of these rows based on ordered by the month, and then we will be subtracting those row numbers into multiplied by 1 month interval, and then we'll try to form our groups, right? So let's create one more CTE. We'll name this as ordered user activity as select user ID, month minus interval 1 month, as we have already discussed, right? Now what we need here is row number. So row number will basically give you the rows based on the, basically it will give you increasing IDs of row numbers to each of the row. And what we need to do is over, right, partition by user ID, order by month as our group. Let's see how does it look like. Okay, we missed the from clause here. Yes, so we get what we needed, right? So it shows 1 is logging in this many times, right? And basically this is the group we needed. And so what we have done is basically we have subtracted 1 month from it. Now I also want you to understand how the month would look like, right? So let's see, let's take the month as well, just to give you an insight. So it was 1, right? And also let's try to give you how does row number look like. So row number as Rn. So okay, so see, what we did is we subtracted 1 from 1 multiplied by 1 interval month, which will basically mean 1 month. So this month minus 1 month, this one minus 2 month, this one minus 3 months, which basically gave me this one minus 4 months gave me this. So we got our groups. Now since we got our groups, the last step in the process will be finding the user ID, from month, ordered month activity, group by user ID, and group having count greater than equal to 6. That is it. So we got the users who have logged in at least 3 times in a month, and they have been doing that for 6 consecutive months. So with this, we have solved most of the problems that I was planning to solve in this video. Moving back to my notepad, right? So moving back to my notepad, what the next questions that are there that I planned for today are basically order of execution in a SQL query. So basically what this question means to understand that, we need to move to our GitHub repo and find the question number 3. The question says write the logical order of execution of different clauses in a SQL query, right? So they will give you a SQL query and they will give you the task to write the order in which these clauses will be executed when this SQL query runs on the compiler. So this question is pretty much self-explanatory, where you need to just remember the order in which these different clauses work. So first will be the from, then join, where, group by, having, select, order by, and finally the limit clause. So this question will basically is a pretty much commonly asked question, and this is one question that I like to read before my interview starts so that it remains fresh in my brain and then I can tackle it if it comes in my interview. Okay. Again, moving back, the next question is SCD type 2. So this basically is solving slowly changing dimensions type 2. And this problem will make much more sense once we cover the dimensional data modeling that I am planning to cover in the next video. So once we understand what are dimension and fact tables and how we implement SCD type 1 and type 2, we'll try to solve this SCD type 1 and type 2 question in SQL and PySpark. Finally, I also plan to solve a few StrataScratch problems. So StrataScratch is a platform that has similar difficulty level of questions, I would say. So if you filter out the questions using hard difficulty, you will be able to find similar questions. And I can show you the same in my GitHub repo. So these are the questions that I planned to solve in this particular video, but the video has already crossed the length I was planning for. So I am planning to take these questions in a part 2 of the week 1, where I would take similar questions and I would plan to take around 10 questions from StrataScratch, and we'll divide the questions in PySpark and SQL and try to solve similar difficulty level questions from the StrataScratch platform, right? So with this, we have come towards the end of this video. I hope you liked it. So I have tried to compile all the patterns of questions that are being asked in the uh, interviews for a data engineer. So if you have followed the video till now, make sure you hit the like button, right? Make sure you hit the like button, guys. That is important. And make sure you share this video with your friends. And as I am sharing my knowledge that I have gained from my interviews, I would also expect you to do the same by sharing your valuable feedbacks in the comment section, right? And once you do that, I'll be able to improvise and you will be also be able to improvise your skills in this area. So with this, let's wrap up this video and hope to see you soon in the next video of dimensional modeling.